Yeah, the YouTube one looks like it stopped about a minute before the last presentation ended.
Yeah.
Oh, that's too bad.
It's like, yeah, when Will was showing the Crab Nebula.
Yep.
That's my luck. I apologize to everyone. That's the way things go for me.
You guys still see it streaming now or not?
No, it shows that it ended. And I've personally had trouble in the past resurrecting a stream that died. I don't know if
refresh your page.
Okay.
Refresh your page.
Does this mean we all have to do our talks over again?
Yeah, you have to do it.
No, I'm still showing a complete video on here.
That's what I'm seeing too on Facebook and stuff.
Okay, it says live now. Okay, yeah. Okay, so if you go to, instead of refreshing the page, if you go to YouTube, look for Explore Alliance Global Star Party, there's a live now that is a new stream, actually. I think it doesn't have all of our chat history here.
We still have I still see people chatting here, so.
Yeah, people are coming back in. They're figuring it out. Okay, well, as people come back in, let's go ahead and press on with Roy's telescope views, and as people figure out how to get back. I'm going to go post the link to the current on the other videos. So yeah, Roy, go ahead.
Okay, so you can see my my all sky camera still, right?
Yes. Yeah.
Okay. So that's just the field of view, or the skies that I currently have outside my observatory tonight. You can see there's some light pollution from Las Vegas, and some from some of the other cities by, but you can see the Milky Way, and it's still, the moon's starting to show a little bit. It's not over the horizon yet, but the skies aren't as dark as they usually are. So what I can do is I can show you some of the images I took about half hour ago. And we can start with, let's see. We'll start with this one. So that was, that's M101. It's taken with my Explorer Scientific 152 millimeter refractor. It's got a 0.7 focal reducer in it. So it's not it's a good wide field. And I'll show you a quick image later about how this field looks really wide. But you get a good view of the galaxy here. There's a galaxy in the lower section and a couple of planes flying through. This was done with a luminance filter at 180 seconds. So the next one I took is M81. And you can see it got a little darker out, so it's got a little bit better image in this one. But you can see some nice galaxies in here. This is, again, with a luminance filter, but this is 3 minutes. And if they were to zoom in on a lot of these, you could see a lot of galaxies. You can see 3 main galaxies here, but there's a lot of little galaxies in here that really come out pretty nice. Once you start stacking all the images together, they actually show up really nice.
Yeah, that looks real nice. That's M82 up on the top there?
Yep.
Okay. What's the other one?
The one in the middle, M81?
No, is that a galaxy on the lower left?
It is, but I'm not an astronomer, so I don't know what it is. I'm a photographer.
I saw that. Yeah, I can't remember offhand which one that is.
I tell this telescope where to point, it goes there, and then I take the picture.
Let's see. M81. Whoops. Let's back up a bit. It looks like it is Oh, it's going to take me a bit to go hunt it down. But yeah. Okay.
Then I decided, let's move over to some hydrogen alpha and get a really good image.
Yes.
So
Oh, yeah.
there's the Rosette Nebula. That's another 5-minute image, 300 seconds with just hydrogen alpha. And that shows off the really good field of view that this telescope has.
Yeah, I can't get enough hydrogen alpha, especially on those big nebulae.
Oh yeah, it's
great.
really nice. If I can go over to it and let me see if I can zoom in on this a bit. So right in this area here, you can see some of the really nice dust lanes that are going to show up in here. And once you have some good signal in this through maybe 10 or 15 different images and stacking this together, it really comes through really good. There was a presentation I watched last night from a couple of nights ago on the Astro Imaging channel, where he was. I think you were on there too. That it showed him putting this through PixInsight and bringing out a lot of the detail, which I'm going to love to try some of that stuff with this images.
There's so much in the Rosette.
Really brought out a lot of detail that I didn't know was even there. Yeah,
there's the fingers of the dust, the molecular dust down there in the lower left of your image. There's some Bach globules that are kind of like little detached droplets of molecular cloud that you can see in there. If you really zoom in and poke around, all the delicate, intricate streams of hydrogen up in the opposite corner. There's just so much to see there. It's gonna be really nice, all processed.
Right.
It's already really nice.
And that was just one image. So I can imagine if I went tonight and which I didn't think it was going to be very good seeing tonight. It's not bad. This is not guided or anything. So
nice.
And I think the only other one I had, I took one of the Eye Nebula, but I didn't get it processed. I didn't get it downloaded in time, and it's tiny anyway, so it wasn't going to be that good.
Okay.
So I figured I would show at least one that I've done in the past and I fully processed.
Sure.
And that is that one.
Oh yeah, that's the Veil Nebula. Is that
yeah?
Is that
so that was done in narrow band as well.
Nice. Yeah, that's another example of really intricate gas. Obviously it's getting late. My brain is losing words. all those little tendrils of gas and it's really cool to do it in narrowband because you can see where the different, like where that shock front is and where the other gases are glowing in their respective colors, and because they're not all in the exact same place, and there's so much interesting stuff going on there. And of course, knowing that it's a supernova remnant just makes it so cool because with the fact that we can see it, you can see it with the telescope, you can see it really well with the camera, and we're seeing what's left over of an ancient supernova. It's so cool.
Oh yeah, I really love this image. It's it shows a lot of detail.
Yeah,
and it shows a lot of just I don't know, just what's out there. I mean, this is a huge complex of all this dust and gas. I don't even know how big it is, but my guess is that our solar system is just a little speck in there.
Yeah, it is enormous. I can't remember offhand how many light years across it is, but more than one. So
right.
it's bigger than the entire solar system. So
yeah, oh, definitely.
Crazy, yeah. All right, well, thanks so much for coming on and sharing some mostly live views, earlier from this evening views from your scope. And it's good to have some astronomy pictures on a Global Star Party show.
Thanks for having me.
Yeah, thank you for coming. Next, I I lost track of a little bit of time. It's been more than a half an hour since the drawing. My apologies to Terry and her Eastern time zone.
No problem.
So yeah, Terry, tell us who won.
All right, let me share my screen while I'm setting that up. I'd asked for some information because I was kind of interested on our outreach award, what our actual numbers were. Let's see, there we go. And so I just got these answers. We've given out 1,228 individual awards on multiple levels. These rewards reflect 28,819 events, 90,860 volunteer hours, and representing 4,096,052 face-to-face contact by volunteer astronomers, which is amazing.
That's incredible.
Yeah, it is. It really is. So, okay, I'll make this quick. And that's on question 3. So let's try to go back. Question 1. Venus is the hottest planet in the solar system. The winner is Christy White.
Okay.
Question 2. 1 million Earths can fit inside the sun. And the winner is Michael Overacker.
All right,
Do the
Michael.
applause noise.
And question 3. If you could lump together all the thousands of known asteroids. Scott, are you playing again?
Yes. I figure if I can lose the stream, I can at least play. So
There you go.
That's always the appropriate time for those little sound effects, right?
Yes, it is. If you could lump together all the thousands of known asteroids in our solar system, their total mass wouldn't even equal 10% of the mass of the Earth's moon. And that is true. And the winner was Israel Monterosso.
Awesome.
And that is it. Again, we'll be back on April 23rd with Astronomical League Live 5. I'm sorry. It's getting late here. Early, I should say.
It's getting pretty late where Terry's at, to be fair.
I'm getting
Terry doesn't sleep. So
Yeah, 12:30 is small change for for astronomers. We're just getting warmed up.
right.
Oh, thank you, Molly. Thanks for inviting me.
Yeah, thank you for coming on, and
Glad to.
All righty. So I know we're running pretty far behind by this point, but I mean the talks are so good and there's so much to say. I hope you will forgive me for not clamping down on that tighter. Our next speaker is another friend of mine, Anna Parra. She is another member of the American Association of Variable Star Observer Ambassadors and has recently put together a pretty sick telescope rig that I hope she does at least a little bit of regular astrophotography with, in addition to all of her scientific imaging. She's an aspiring astrophysicist and amateur astronomer that does exoplanet research. She uses AstroImage J to create light curves on TESS candidates. TESS is that transiting exoplanet something survey that is looking for transiting exoplanets. Her journey has been challenging but rewarding and suggests that the keys to success are having mentors, being a mentor, having patience, and having a good internet connection.
Oh.
Vital in today's climate where most of our assistance is delivered remotely. So Anna, super happy to have you on, and please tell us about exoplanets.
Okay, thank you. I'm gonna go ahead and share my screen. Okay. So yes, thank you for the introduction, Molly. Let me see if I can. Okay. Yeah. So once again, my presentation is about creating light curves of exoplanets or test candidates and using AstroImage J. And sort of before I dive into that, I kind of wanted to just give a quick backstory as to like how I got involved. I was a student of Voice Astro's program for double star research, and from there I learned about their exoplanet research opportunity, and that was in coordination with the AVSO, and they call it the Explorers program. And as I mentioned before, we use a very specific software, AstroImage-J, to create light curves of exoplanets or candidate exoplanets. And so I'm a part of a team with Pat Boyce and Scott Dixon, and I'm currently sort of like at the lead of understanding, how to create, final submissions for test candidates onto ExoFOP tests. And so I'm going to be going over just the steps that are involved. I'm not going to be using the program itself because I feel like that would just take too much time. So I did my best to just capture the main points of using the program and how in depth that, how much research goes into it and all the fine adjustments that go to making a really good light curve that I'll be showing at the end. And so, so let's go in. So luckily with the Explorer program, Pat Boyce has a server called Bark that that he puts the images of test candidates or exoplanets, and and so he provides that to us, and I'll go a little bit in depth about that. And so we have everything formatted so that it's really easy for people to just jump right in and get going with the analysis of these images and create light curves. And so right off the bat, he puts, these three main folders, the AIJ analysis, quarantine images, and science images. And what you'll find in the AIJ analysis folder is really three good starting important documents, which I'll go into in a little bit. We got the worksheet, the measurement template, which we'll go into a little later, and the notes template. And let's go to the next page. And so when we decide on a test candidate, it's really important to get some history about that candidate when it was observed. And so the first thing you want to look at is at the comments of the TTF. And there's a website, I forgot I should have put the link on there. It's like Swarthmore or something like that, but I call it the TTF, and they have comments, and the comments tell us exactly the purpose of taking the image of this target, and that will dictate how we analyze the target on AIJ. And so this, if it says to, observe this target in a certain filter, you got to make sure it was done at that certain filter, or else, you weren't completing the goal of this target. And second, which I'll go into a little later, is like confirming that the target occurred during the transit time. A lot of the times, and that happened to me recently, you get these images and you're excited, you're going through the process of analyzing them, and then you find out the plot is the curve is like starting way before the predicted time and doesn't even fall within the predicted transit time. And so those are like the top two things that I emphasize to myself and to others who are trying to do exoplanet transit analysis through AIJ. And as you see here in the bottom here, the TTF, this is a screenshot, it gives some really important information about it that we will be writing down later on. But some things to note is, the predicted ingress and egress, it's in BJD, TDB, I forgot what it stands for, but that's the timestamp that we use. And we focus on the time behind to the right of the decimal. Of course, we want to know where to locate it in the sky, so we have the right ascension and declination. And then the period, how often this transit occurs, and the depth of the expected depth of the transit. And a lot of times for our program, we get a lot of level 3 priority for this. And so let's see what else to highlight. And then just, of course, it's really important to know what you're targeting through the TIC, or its other name, the TOI. So to highlight again, if you want to analyze a test candidate, before you even start, just look at the comments and in fact, copy the comments into this final submission note file here before you move forward. So this is the worksheet. I think maybe Pat or Grady put this worksheet together, but I've actually went ahead and modified it because I felt like it was missing a lot of things. But this is what you're given. This worksheet is part of the preparation phase of the analysis. And so I pointed a few things out where we can find like the right ascension, declination, and on to the right, you'll see that things are abbreviated as to like where to find them. Some of the stuff is given. You can go to certain websites and it's already, the information's already there, but there are some things that are calculated based on what you find. And I'll go into depth about, the different places where you have to find this information. But this is the worksheet. This is what you get right off the bat in the AIJ analysis folder. I'm still trying to learn what the limb darkening coefficient is, but I know it just helps with creating the light curve and optimizing it. But there are some things that you have to get from the XOFOP website, which I think is on the next few slides. So there's some crucial information that you need, such as the filter, the log G, the iron over hydrogen, the metallicity, and the temperature, the effective temperature. And so it'll give you two coefficients that actually you would need to insert into the worksheet. This is the XOFOP. This is where you find the test candidate information, such as the some important things is, like I said, the log G, the metallicity, and there's other information you can learn about it, but there's only a few things that you just need to like take from it, which will help optimize the light curve, which I'll show later. So how do we get these images? We are part of the Las Cumbres Observatory Global Network Telescope Network. Specifically, we've been using the 0.4 meter telescopes, and they made identical telescopes, and they put them at different parts of the world. And they all carry a SPIG STL6303 CCD camera. If you click around on this website, you'll find like very detailed information on these telescopes. But we also have access to the 1 meter telescopes and I think 2 meter telescopes. But most of our observations have been done in the 0.4 meter telescopes. Okay, so we're still in the preparation phase, and what's really important when you get these images, they have a FITS header that has a lot of keywords that need to correlate with the TTF. You want to make sure that when you're looking at the FITS header, I don't have it here. Oh well, I guess so. So you want to make sure that that the observation was done at the right time, that that the longitude and latitude of the observatory lines up well, and there's a few other things that you just need to look to. So I guess before you begin, you need to make sure that the FITS header information lines up with the TTF before you proceed forward. And so I kind of gave some screenshots as to like the order and how you get there. So this here on the top, the AstroImage J, this is like the toolbar. This is what opens up after you click on the AIJ icon. And in order to import things is, you go to File, and then you just import and then Sequence, and it comes up with the amount of images that you have. And below you will see that this is just like an example of what your image would look like. One of your science images will look like. Also part of the preparations phase, it's really important to go through each image to make sure that to weed out the bad images. So sometimes you'll see these streaks, random particles coming around, and sometimes when you open it up, the brightness may be really really dark, so you have to play around with the brightness using this histogram here. They got these sliders here, the min and max, and you play around with that, and you can really show some faint stars. I highlighted this here, the orientation of the image. A lot of the times, at least with the LIGO, they don't orient. You can't fix that orientation the way you would like to, north, top, east, right. But the best that you can do if you become an explorer and you do AIJ analysis of these test candidates, through the program, then this is as good as it's going to get most of the time with this orientation. So in all these bad images, as I mentioned, there was 3 main folders that we set up for you. These images get dumped into the quarantine so that only the good images are left into the science image folder. So the second phase is the calibration phase, and something to highlight, if you're part of our program and you get images from the LCO, a lot of these images have been calibrated and plate solved through this OSS pipeline, which is really nice. It just makes the process faster. There's only a few things that you need to do, which is, make sure that the directory is correct to your science images, that they have the correct file name, that the total amount of images after you remove the quarantine images is correct. Making sure that the target coordinate source is based on the FITS header target and right extension and declination, and that the observatory is found using the latitude and longitude values. I don't think this down here is supposed to be 16, it's supposed to be 32, but this is an old image. And so it usually before, in the very beginning process, when it was several years ago, there was a lot of clicking and getting to the right file for the bias, dark and flats, and adjusting a lot of different parts of this. And it was a bit confusing for, beginning amateur astronomers. And so it was really nice that Pat and Grady were able to just kind of streamline this process for us and get to like the more fun part. But if you were to do this, if you were to observe your own exoplanet, you would have to learn how to do all this other part, which I'm not able to explain just yet. So, I also highlighted this part here in D, and that's because in the next slide here, that little wrench icon opens up this left image here, and it's really important that there's certain target words that need to align well with the FITS header. So that's another step that can't be missed if you're processing these images. Okay, so this part here, phase 3 is sort of the funner part, but a little bit more complicated. There's a lot more steps and a lot of things to kind of keep in mind. So once again, you upload. Okay, so you take all your bad images, you got your good images on the science images, and now you're gonna start all over, open up AIJ again, and then open up your science images, and you want to use a feature called the plot sync profile. And so you do this. I think it's alt-click onto the target, and you find the target. You can see in the screen that there's, on this image screen here, that there's RA and DEC, and when you put your cursor over these dots, the coordinates will show up, and so that should help guide you find the target. And you want to use, I think it's alt-click, and this plot sync profile on your right comes up, and it shows you where the aperture, well, this is half of it, but the aperture, the distance from the center to the end of the aperture has a radius of 4. And let me move my screen really quickly. And then you see that the next, radius of 4, and then you get to the inner annulus, and has a radius of 7, and then the outer annulus a radius of 11. And so these numbers are really important initially and towards the end of your AIJ analysis. And I wish I should have done this, so I'll do it in the future. Show why it's important to have these values and what this looks like in regards to the calculations that are done with the photometry part of this, but I don't really dive into it this time. But yeah, remember those numbers. Well, don't remember them, but realize that we use these numbers, the apertures and the annulus, to help optimize our light curve. So let's see. Okay, so we have our images, we do our plot sync profile, get our radius for the aperture and the annulus, and we go ahead and start, and this is all based on the TTF comments. Like I said, the TTF comments guide us as to what we do for this. And so we may not need to do this for certain targets, but if it does ask to check for nearby, and I should have clarified, it's nearby eclipsing binaries. That's what NAB stands for. So if an event were to occur, there's a possibility that it could have came from the target or from a nearby eclipsing binary. And I believe that the test has a really bad resolution, and that's why we do a ground-based observation, is to like verify where this event occurred. And so we use this website. I should have had the link. We use this website got from Gaia that allows us to access their database for possible NEBs within this radius, 2.5 arcsecond radius, and we use the data of the observation in UTC, the right extension, the declination. We enter the test, which we found on the ExoFOP website, and the transit depth, which we found in the TTF. You use the TIC coordinates, submit, and it gives you this file that you can download, and you can literally just like look up that downloaded file on a folder and drag and drop that file onto over the image, and these green circles with the letter T and numbers pop right up. So it's really simple to just get that part going. And then from there, it's really important to draw this radius around there. I'm still trying to figure out why exactly, but we do that. It's part of the protocol. And let me just like give a quick comment. There's a lot of things like I'm still trying to understand, like why are we doing this? So I'm learning how to do the process, and I'm also learning like why we do this. But oh, and something else I forgot to mention too is and you'll notice that I'll put final submission on top of a picture, and it's just to show that this is used as the final submission files for ExoFOP test targets. And so I just sort of highlighted with this different kind of font, and I'll show the final submission files at the very end. But we have a field image. We want to have an image where we see the whole field, get all the comp stars in there, all the possible NEBs. As you notice, the orientation is as good as it can get there. And then we have a zoom in version of it, because we want to be able to sort of look at the possible NEBs or the NEBs that could have caused that event, and just distinguish it from the target if possible. Oh, but that one's interesting. North is top and east is right, left. Okay, I don't know why. So we got our NEBs, we drew our circle, and now we want to create our comparison stars. And so we need comparison stars to create our light curve graph, which I'll show later. And this part is done by selecting the multi-aperture measurements icon here in circle. And it pulls up this multi-aperture measurements screen. And this is where we put in the radius and the inner outer annulus, or the aperture and the inner outer annulus radius onto this screen. And you'll notice here, this is not check mark, but for NEBs, this would be check mark. We would use the RE deck to locate aperture positions. Similar here and similar here. And when you click on the aperture settings, this part comes up, this aperture photometry setting screen comes up. The radiuses should transfer over. However, I don't think this is reflective of the 0.4 telescopes that we use, but yeah, so you would have to update this as well based on your camera features. And then from there, you are good to go. And you can go, what it does, it lets you start clicking and putting circles around stars, and they define it shows up as red, C, and then a number. And when it comes to comparison stars, they say that it's really important to use like similar stellar type, but a lot of the times you're going to find that you don't have that information. If you're lucky, that's great, but most of the time I haven't been lucky with that. And so the best thing that you can do is find comparison stars that have similar integrated counts that you see circled up here. And so, and the reason why it's integrated counts rather than peak or value is because there is this paper, I think Karen Collins is in it, but a lot of their formulas, equations for when it comes to comparison stars, they use the integrated counts, and so we just use that to help guide us. I like to select like up to 12 comparison stars if possible, because there's this optimization part that's done later that really reduces the amount of comparison stars that you have at the end. And then a lot of that times too is, you're not going to find comparison stars with similar integrated counts. You're going to find some with very high numbers, very low number. And so what is taught to us is, find the equal distance above and below the target integrated counts, and this and hope. And then you would obviously not want to choose variable stars too in this. And you'll see why. It's because when we create that light curve, we want those comparison stars to have just a flat line, and then obviously if our target has an exoplanet, you'll see a dip, which we'll go on later. Okay, so with this part, you put all your comp stars and you're like, okay, I'm done. You click enter, and I kid you not, all these screens like pop up at once. They pop up at once. You're like, oh my gosh, what's happening here? There's a lot going on here, and all the different screens are equally important. And I'll go through them one by one quickly. But one thing to know, I kind of gave like a sneak peek. No, this is not my target, by the way. I've been pulling from different places, so I haven't given any because I feel like mine haven't been officially submitted, so I can't give out the information yet, I guess. So I just gathered some information from different places. But so one thing that needs to happen right off the bat is when you click enter, this measurement table, it gets filled up until all your images have been processed. And from there, it's really important to save this file, because if you ever need to go back, you can just open up this measurement table and start from there. And then also too, there is that plot document that I showed you at the very beginning. I should have screenshot it here, but that you have to open it up to sort of start fresh again. A lot of the times when you're using AIJ, it uses previous values from a different run, and you have to make sure you follow our protocol step by step, such as like opening up, a new plot configuration file, so that you start fresh and it doesn't transfer the old values to your new target. This is the multi-plot main screen. It's not filled in, but some things to highlight is that our default X data axis needs to be in BJTDB. It's not the case there. The V marker 1, V marker 2, this is where you would put your ingress and your egress when the transit occurs and when the transit ends. There's this button down here, the copy, that transfers those numbers here. And I'll show you a light curve on how that looks like. But later on, you're able to optimize the light curve by deciding what the observed ingress and egress values are, and you can actually just then enter them down here and keep the predicted ingress and egress. The title, we have a set of there's a way to title your light curve and how to do the subtitle. Most of the time we do auto X range for us, and then I think this does it automatically, and there's not too much after that. And so the next important screen is the data set to fit settings. This is where we insert the information we found on the exofop, which is the periods. Unfortunately, we do not know the radius of the exoplanet, so the best thing that we can do is do the effective temperature. And then remember that limb darkening coefficient website. This is where you would insert this data. And most of the time, the detrend parameters are defaulted to air mass. And that actually gets adjusted a little later on, which I'll go into, which helps optimize the light curve. But you know you're doing well with this screen if these boxes are green. If they turn red or they turn gray, you did something wrong. And I don't, you have to figure that out. Here to the right, I guess, is the remaining of the screen here. Something that to note is the RMS here under the FIT statistics and the BIC. I forgot what they stand for, but I know they're really important to optimizing the light curve. The lower the number this is, the better the noise that occurs on the comps, on the I think it's on the comp stars, or it's the noise that occurs before and after the transit. It makes those lines more horizontal, and I'll show you that in a little bit. But you'll see later on I have this worksheet that I have you write down what these values are. And so those are the important parts of this window. We have the multi-plot Y data screen. There is a lot going on this page. Just a lot, but the main idea is this is, you select which data points you want to have plotted, and I'll show you what the light curves are, but most of the time we have the light curves plotted for just the target, and then one for the comparison curves. There's a lot of it's just a little too cluttered, and you get to color code them yourself. There's certain things that you have to do to optimize, to just kind of set the light curve based on some of these features here, like the bin. This part here, there is a standard to have, the target scale at 1 with 0 shift. And so our protocol has it lined up just like step by step for you so that you don't have to figure it out on your own, which is really nice because it gets very overwhelming looking at this page. So this is the light curve that can be made if you're lucky. So as you see here, there's 2 light curves. There's one on your left, which has the target. We have one on the right that's just the comparison stars. You can see obviously that the comparisons are, more horizontal than the left. Additionally, there's all these other light curves. Oops, sorry. There's all these other light curves. There's all these other curves that must be plotted onto the target with the target, and some things that I'm still trying to understand how to explain some of this, so I won't go into it until but there's some cool things that you can do. Not just, you don't have to. There's some really helpful things that you can do to maybe see if you're using the right image for certain values. So for example, the plot scene profile that we did a few slides back, that was based on the first slide, the first image. And we're assuming that the first image is, it looks good, it doesn't seem like a bad image. But if you go ahead and you plot, like, for example, the full width half maximum, which is not on here, you can actually see, like, if there's, like, a nice horizontal line, or maybe there's this, like, beginning, like, it's high and then it goes all the way down and it's horizontal. And that, like, gives us a glimpse that, actually that first slice wasn't a good image. And you may actually want to discard those images that were higher up on that full width half maximum. What happened?
Oh, about how much do you have remaining on your top?
Not much.
Okay.
Yeah, sorry, I'll keep going. So there's some cool things that you can do to figure out which images are bad, which ones are good, and just like optimize your light curve. And so this is just a macro that's installed into that you can upload onto AIJ. Just helps you determine if these NEBs were actually an event or not. So that's really nice. And sometimes you need these and sometimes you don't. As I mentioned before, there's ways to optimize the light curve by seeing, and there's a way to calculate this, what's the observed predicted ingress and egress, because sometimes it doesn't align with the predicted. This here, and this is I think this is towards the end. This is something I created actually. There is a section on Dennis Cortese' guide. I think it's like section 11 or something. and it's the most confusing part of his guide. It doesn't really go step by step at all. I mean, it sort of does, but it doesn't. And even when I talked to him in person, you know, he gave me, he rearranged the order and how to do this. And so I wrote it all down, did it, and then I realized I can't just verbally share it to somebody how to do this. And so I just went ahead and put this as a second tab on that worksheet on how to optimize a light curve using the D-trend parameters. And there's even a part where how to optimize a light curve based on changing the aperture and annulus radius. And so you just put some numbers in, and you get some numbers out, and you choose those numbers, and hopefully it fixes your life curve. And so these are all the files that you submit at the very end. They have to be the right format, the right file format, and they go ahead and upload it to XOFOP. That's it.
All right, thanks, Anna. That was a lot of info.
It's okay. Just a background. It has been a struggle. I've been meeting with Dennis Corti regularly, asking a bunch of questions. I honestly, without his help, I don't think I would have learned this much. And there's still so much to learn about. And I guess I'm like one of like many people he like answers questions all the time. But I'm currently a mentor for somebody, so that's really helping me.
Yeah, it's a good way to learn
better understand it. Yeah, she's a high schooler, and she was just like, I want to do test targets and write a paper. And I'm like, wow, okay.
That's cool.
Let me help you because you're gonna need it. So yeah, it's what's also just to highlight, you know, there is a guide, and it does seem overwhelming, but luckily that guide does that step-by-step process for you. So it's not too much, but
yeah, and looks like you just kind of get into it bit by bit. I mean, it's just like astrophotography. There's so much to know, but you just kind of learn it one step at a time, and also teach other people at the same time, and you can kind of pick it up.
Yeah. So
all right. There you go. Thanks so much for coming on, and I know people are really interested in exoplanets, and amateurs can get involved in this research, but by doing the analysis. If you're more into doing that side of it, of a professional telescope targets, or there's even ways for amateurs to be able to collect data on some of the deeper transits as well. So yeah, amateurs can get involved in exoplanet research, which is super mega awesome sauce cool. So
yeah, and if you have questions or you want to learn more about this, you can totally reach out to me, and I can help you get started.
Yeah, awesome. Yeah. All right, thank you again, Anna.
You're welcome. Let me stop sharing.
Okay, thanks. And it looks like it's about time to take another break.
Okay, all right.
I got to run outside, and one of my camera cables isn't plugged in properly, apparently. So okay. Run outside and jiggle that cable a bit.
10-minute break and come back for more of the Global Star Party 39. How you hanging in there, Cameron?
Hey, Scott, can you hear me?
Yeah, I hear you fine.
Yeah, I have two things going on. Am I still on the other frozen screen view as well?
On a frozen screen. I see. Yeah, you look frozen.
Okay, yeah, and then there's another instance of me, right?
Yes.
Yeah, so the one I'm talking on right now is outside, and I'm actually doing a bunch of imaging, or just smartphone shots. So I have a lot of
Cool.
fun stuff to share, and then so I've just been listening to all the cool stuff, and really great session, and I'm having a blast out here, taking some snaps, and so and then I also can go back inside, and so, but I think this is I don't know how much I want to share. You tell me, Scott, how long you want to go, because I have as much or as little.
I can go. We'll see how the show goes, and as long as we have an audience, I can do it to a point. It's it's a little bit after midnight right now, so
yeah, I figured that. Yeah, this is really good. A lot of stuff. Molly packed in a lot of good material and a lot of good speakers. Really diverse, and really interesting topics.
Yeah.
Sorry, it's running really late now, but
no, it's good stuff.
The talks were so good, I didn't want to cut people off. So
yeah,
and we had a little speed bump there with our stream breaking, so, which I'm not sure why, but I've had a few instances, not very many, but just strange hiccups in internet can happen. We have we run optical fiber here. We've got roughly 200 up and 200 down, which is
nice.
Which is pretty good,
Oh yeah, that's nice.
Mm-hmm.
Yeah, I'm just taking some snaps of the Whale Galaxy right now.
Oh, nice.
Not it won't be nice. It will be good enough. let's put it this way.
It's going to be really good. So.
Yeah. You know what the cool part is? What I like is I think Simon said it in one of the previous episodes. See what you can't see, right? I mean, basically, what I'm able to see with my smartphone here is stuff that I would normally have to go to a dark sky.
Yeah.
And there's even a little bit of moon glow, and so it's pretty nice to be able to see like details in the Whale Galaxy with an 8-inch Macassegrain.
Yeah.
And the companion galaxy, just by playing around with the smartphone. It makes it kind of like a hybrid experience, right? You're both visualizing, it's real, you're there, and at the same time you're seeing the image kind of enhanced. So it's really nice.
Very cool.
It's not a beautiful picture, like what the professionals do. I'll get there though, but this is it's a different type of experience, and it's kind of like observing plus.
Yeah, right now I'm imaging some relatively diffuse and kind of dim planetary nebula. So the individual shots you can't see much, but once I go and stack them, they should pop right out. So I've got a picture of the Medusa Nebula that you can just barely see it coming up on my color camera with the LX Stream filter. But the next target is running right now, M81 and M82, and that one I'll be able to see in a single frame.
Nice. Yeah, I got for Libby in the stars, I got a snap of Cat's Eye Nebula.
Excellent.
And then I got NGC 40 as well.
Excellent.
Let's see here.
Yeah, Cat's Eye Nebula is one I've tried before, but way back when I didn't really know what I was doing with the DSLR. But now it's on my list to do. It's in a difficult spot for me because a lot of my northern sky is either blocked or partially blocked. So it's on my list to do when I go out to the dark sky site where I have a clear northern view.
Well, you're another 10 degrees south of where I'm at. So I have an advantage. I'm at 47.5 or something like that north.
Yeah.
So that helps a lot. So I can see a lot of the northern stuff in Draco and Cassiopeia. For example, I was able to get the Nova again tonight.
Oh yeah.
So I just took a quick picture of that as well.
That's nice.
So that was
yeah,
kind
that
of cool.
one's like right behind my house. I have a very, very tiny backyard, so my everything is near to the telescope, so my horizon is just very high up in the sky. Except for south, I happen to have a very nice view toward the south.
Yeah, that's nice. And actually, where you're at, you have pretty much the bay, so you have the glow of San Jose, I guess, a little bit, right?
I'm further north. I'm up in Berkeley, so I have the glow of Oakland and San Francisco to my south. But as far as like the houses and fences that are in the way, that's the least obstructed view. But it's bright everywhere except the ocean is to my west. So there's that.
But you have filter technology. So it's...
yeah. I just got the LX Stream not too long ago, and that's going to help a lot with my color camera.
I wonder if what you could do is, how there's a Bayer pattern on a single shot camera has the RGB or whatever, right?
Mm-hmm.
I wonder if you can make it tuned so that it can be more the green can be more S2. Tuned towards S2.
They'll split they'll extract the color channels and recombine them in the Hubble palette with like the L Enhance filter or the L Extreme. I've seen people do it, so it might be fun to play with at some point.
That would be awesome. Yeah, because usually what happens is the O3 and the H alpha comes out pretty strong with luminescence, right? Because it's in band for the red and the blue.
Mm-hmm.
Sorry, red and the I guess it's blue, yeah. But the green in the S2 is a little bit off. Like S2 is kind of close to O3, I believe, right? So you kind of have
it's down in the deep red, but it's usually assigned to be it's assigned to be red in the Hubble palette.
Right.
Unfortunately, in both, it's so close to hydrogen alpha that unless you get a quad band filter, it's usually not a separate signal, and it's gonna show up in the red on the Bayer filter anyway.
Right.
It does make it a little more difficult, but there's stuff that can be done. All right, so to get back onto our schedule here, we've got some live views from, I guess, is that Cameron who's up next, or is Gary here? He's not here, so Cameron, it's all you.
Looks like Gary didn't make it. Yeah.
Okay, so let me I'm going to do a couple things here. I'm going to first of all give you some semi-live views of what I took a picture of tonight. I got my 8-inch. It's a beautiful night here in Seattle, really rare, but it's been very, very nice. The moon is still over the horizon, so it's dark enough to take some pictures of galaxies and stuff. What I do is, let me share my screen here. Yeah, let's see here, share. Where is it? Screen, there we go. Start now. Okay, can you see my screen?
Yeah, that's cool.
Okay, so let me go to, no, let's go to this one here. Okay, so I took a bunch of pictures. So first thing is, this is the supernova in, or the nova in Cassiopeia. This is the near SAO 20610, and you can't use a pointer here, but basically the supernova is just north of where that star is. Okay, so now if we go to the picture, there, if I go here, you see that's it. So this triangle on the right is the other triangle, and those two stars. So basically it's right. SAO 2610 is the brighter star on the bottom, and then this star right here is the new nova. So it's quite bright. So it's not an awesome picture, but it's kind of neat to be able to find that.
Yeah.
Then I moved along to NGC 40 because it was in the vicinity,
Oh.
and so here's an NGC 40 pic, and then I played around with some of the exposure. You actually got a little bit of color in this. This is kind of interesting.
Wow.
After 30 seconds, here's the Cat's Eye Nebula for Libby. I got a couple actually. There's one that I got which is really good. This is pretty good. Yeah, this one here. This is pretty nice.
Yeah.
So I highly recommend Libby. You have a 10-inch, right, Dobsonian?
I think she's not on.
It's kind of late, I guess. Yeah. Yeah. So
yeah, probably past her bedtime.
well, when she watches this in the morning or whatever, I highly recommend Libby. You look at Cat's Eye Nebula. It's a beautiful object in a Dob. Beautiful. You can see the crystal clear central star and a nice shell. It's really nice. And then this is M101, really diffuse. You can barely see the spiral arms. This is a very difficult object in my Bortle 6 to 8 skies, but I got it, which is good. And then this is this is the first. Here we go. Now I got a series of M51 pictures, so you can actually see the spiral arms. So if I go through and let's go to, here's a pretty good one. You can see the spiral structure pretty decent. If I play around with some stretching and I took a number so I can stack them. And then just for fun. And then I'm going to use Deep Sky Stacker, just stack a couple of frames together and enhance it. I should be able to pull out the spiral arms pretty easily, but it's really nice to be able to see that.
Can you take them in using the Pro camera so you can have the raw format?
I don't, what I do? What I do, Molly, is I did that, but raw format is massive. Like it's like one picture is like 24 megabyte or whatever, and it's very pixelated. I'll get there, but for now I'm just having fun with like what I'm doing actually is I'm emailing myself 10% compressed pictures and I'm stacking those. So it's it's not awesome, but it's kind of fun. I'm just kind of learning the techniques, and then what I'm going to ultimately do is I have to have an astronomy camera, have it all automated, and and then do live stacking and stuff like that.
What you can do in between those two steps is you can transfer via USB cable. That should speed it up. My cat just slid all over my desk. You can take those raw images. Like I think in the settings, you can turn on save out a RAW in addition to your JPEG, and then you can plug it into your computer via USB and transfer those larger files over to your computer without having to wait for them to upload and then re-download to the cloud.
Oh, cool. Oops, my computer fell asleep here. Give me a second. Okay. Yeah, that's good. I do want to tether my phone and do that. That would be the way to go. Then I got, I love M106. I just love M106 because I love how the spiral arms kind of wrap around. You can actually see some of the dark central dust lane there.
We lost your screen share.
Oh, let me, darn it. Okay, give me a second. Share screen. Okay, so let's go back. Yeah, so here's M106.
Oh yeah.
And I just love this galaxy. I just love how the arms just beautifully wrap around, and you have the dark central dust area there. So I got a couple of those I can play around with. This is the Sunflower Galaxy.
Oh yeah.
That's pretty good. I'm gonna play with that. And here's the Whale Galaxy. Let me go to a bigger image. Sorry. Yeah, so you can see it pretty good. You can see
pretty small field of view then.
Small. Yeah, what I did. Yeah, I have a 13 millimeter Nagler, which gets me to about 100 and something power, and 180 or something, and then what I do is I use a 2x digital zoom on my phone, and what that does is that actually cuts off the artifacts. I found out there's this infrared thing that always creates a ghost image on the opposite side and in the middle with the lens elements. So what I do is I just crop it automatically, but 2x, that seems to take care of most of the artifacts.
That works,
yeah, and then that's basically all I got. And then what I'll do if I'm going to stop sharing for a second. I'm going to find, give me a second here. And if I have, what the other thing I wanted to show you is, here we go. Yeah, let me share my screen again. Okay. Sorry for jumping around here. Okay, you recognize this one, eh?
That Hubble's Variable Nebula?
You betcha. Oh, this made me so happy. I hadn't seen it for a while, and I looked and I was like, whoa, it's quite bright. And I was like, this is nice. And so so you got a little bit of structure in the nebula. You can see a little bit of the, yeah. So what I did is I played around with this on my desktop, and I stacked 2 images, like really advanced here. Yeah, just joking. I took 2 images, stacked them, and I enhanced it, and it looks pretty good. I can show you later. But basically, that was my Hubble's Variable Nebula, and then and then the moon. I wanted to show you. Then I the other day I got a moon video. So I got this here. That was really nice.
Yeah, that came out nice.
And with my Schmidt-Cassegrain green, and then it was a cloudy night. Let me just yeah, here we go. Is this it? Yeah. So let me put this. Actually, if I
looking at the moon when the clouds are going over it through the telescope.
Yeah.
It's so like Halloween, like eerie. It's so cool.
Yeah, that was really fun. And this was with my Mac 102. And then what did I do here? There's Tycho, right? And you can see I didn't do any tracking here. I just let it kind of coast through. And you can see that it's kind of a neat effect with the clouds and the and the thing there. So anyhow, that's what I have for today. And what I can do is I will see if I'm going to go to what do you call it, Markarian's chain.
Oh yeah.
And I'll let you know when I'm there, and I'll try to take a quick shot of that.
Okay. Yeah, and so something I've wanted to do to kind of prove a point is to do some smartphone astrophotography, especially like on my camera. Without installing a special camera, I can take 10-second exposures at ISO up to 3200, I think, and I can take it in the raw format. So kind of wanted to try some of the brighter targets because these cameras are so like they're made. A lot of people want to take pictures in dark places, and not have a lot of noise. And the pixel, even though the pixels are very tiny, the focal ratio on the camera, its own little lens assembly is usually pretty fast, like f1.4, and the cameras are very, very sensitive, and they do a lot of their own kind of enhancement and stuff like that built into the firmware. So I've been wanting to kind of mess around with that. I have an attachment to attach it to an eyepiece. I don't have any real nice eyepieces. I just have a bunch of Plossels, but just to kind of show like what can be done with a smartphone. And I think a lot of people are beating me to it now, but I got to get on that because I just want to see, because I have one of the nicer, like I have a Samsung Galaxy Note 10 5G monstrosity, and it'd be fun just to see what it's capable of because everybody wants the best cameras and they're really coming along.
Well, you know what's cool about Molly is that this is not even about being first. Like, I mean, I'm way behind, like as far as imaging and all that. I'm. It's so nice to see the people pioneering it and seeing that's where I can go. It's a step ladder, right? You're building. You can do all this, and when you do start to get into smartphone again, it's nice to be able to, kind of rediscover it and then show all the different steps. And technology is also improving all the time, so there's always new techniques and new shortcuts. So it's just really nice to be able to have it accessible and make little improvements here and there.
Yeah, and I think with what I've learned from doing astrophotography with astro cameras, I can probably produce some pretty nice images from the smartphone. So it'd be really fun to mess around with that. And I think I'm sure somebody's got a camera app out there that will let you do longer exposure than 10 seconds. So it'd be fun to mess around with that, do a 30-second exposure. Something, I mean, you can't go real long because the camera's not cooled, right? But, I used to take 5-minute images with my DSLR, and the noise on that wasn't outrageous. It's not as good as a cooled camera, but it was definitely workable. So I think the smartphone would be about the same. So that'd be fun to play with.
I think some people use Nightcap. I don't know if that's for Android, but I know it's definitely Apple people friendly. So Nightcap is a good one.
That is an iPhone one. Yeah, I tried to download that on my Android, but unfortunately something else came up and it wasn't good.
Okay, I'll have to see if there's another version out there for Android. David, also, I meant to ask you earlier, what is this telescope or what you have on your desk there?
Oh yeah, thank you. Thank you. I get a chance to introduce you all to Minerva.
Minerva.
I got Minerva. This is Minerva. Let me try to get this settled so that the camera doesn't fly out of the window. But and then I have to throw the computer out the window after it. But this is Minerva. I've had this telescope since 1967. And
that was like last century.
Yes, it was. It arrived the same week that I was very nearly expelled from the Royal Astronomical Society of Canada because I had gotten into an argument with the director there. And she tried to have me expelled. And at the same time, I think the day after the board meeting where they said, no, we're not going to do that, even though he's a jerk, we're not going to do that. The next day, Minerva came. And I've been using it. I've never discovered a comet with it. I did discover a nova with it, Nova Cygni 1978, independently discovered with it. But never have I found a comet with this telescope, and I've used it probably more than any other telescope in my life. But I just love it, and it's so easy to just put right here. This is not an artificial background. This is real. This is my room, my little David room, and this is my one of my telescopes. It's right here. I can take it out whenever I want.
That's right.
So
that's a nice one.
Like a truss tube Newtonian kind of thing going on there?
It's kind of a truss tube Newtonian. The original telescope had a solid tube and a really heavy mount, but I was stronger and not old then. And I've had about 3 or 4 changes in tube assemblies, 3 or 4 changes in mounts, but the optics are the original optics.
Oh, cool.
And there's an eyepiece here. And I don't know who made this crazy eyepiece. It's a company I know.
Yeah?
Yeah, it's a company. And it's the company is, it begins with an E, but I can't remember the name of it. So it has something to do with...
maybe it's Edmund Scientific?
No, it's not. It's not, Scotty. And this is an Explore Scientific eyepiece. And when I use it, the telescope thinks it's a 16-inch.
Oh, yeah.
I just love this. I just love this eyepiece. And I love working with Scotty. And
what's the box on the lower part of it there?
The box.
It's a label.
No. There's like kind of it looks like a focuser box or the black thing.
This thing. Yeah, this is something I can, when I have a hammer, I can just smash it. This is the Advanced Astromaster made by Celestron, and it actually works. It tells you the approximate RA and DEC.
Okay.
Where I'm doing it, it actually works. I'm really pretty happy with it, and it works.
Awesome. Yeah, I've seen stuff like that on some of the big Dobbs so that people know where they're pointing and can get on target a little quicker.
Yeah, I put one on the telescope I have from Scotty, Eureka, a 12-inch, but I haven't quite gotten it to be as accurate as I'd like. It's sort of there, but it needs to be tuned up a bit.
Okay.
if you ever went into the Jarnac Observatory, you would see lots of different telescopes there. It's an amazing place because of just all the historical things that are also in there. I mean, there's a nice glass plate in there with, I think it's from Bart Bach. Is that right, David?
Yes, it is.
Yeah. And, you know, David's big Newtonian Dobsonian telescope is in there that he's done lots of comet observations and has discovered many comets with, is there. His modified Schmidt camera, which is a 16-inch primary 12-inch corrector plate Schmidt camera that I think Dean from Starzona modified to hold a CCD camera. It once held film,
cool.
so that's very cool.
And that was a Schmidt camera that came from a certain company that Scotty used to work for years ago.
Yeah.
The company begins with an M.
Yeah.
And,
I rescued the Schmidt camera because it had stopped fulfilling its service at Mount Wilson. It was originally installed there to photograph Comet Hale-Bopp. And
what history there is up at that mountain, I got to tell you. It
Yeah,
is
sure.
just, the history just leaks out of there like baseballs.
Yeah.
It's just incredible to see the history of that,
Yeah.
that place.
It's the same. It feels the same. They're amazing places, and it's so wonderful that the Yerkes Future Foundation was able to secure the facility. Ian McLennan and Bill Peters were on with me earlier today, and we were talking about their work at Yerkes. But there's a whole program to help nourish the historical observatories here, not only in this country, but in other countries as well. And it's called the Alliance of Historic Observatories. And our website is about to launch here pretty soon. I think sometime in April, mid-April, will be launched. And so it's I'm very, very pleased to see it come about, you know, so.
That's awesome.
Yeah, that is wonderful, Scotty.
We have our next Global Star Party will be guest hosted by David Levy.
David.
The David, that's right. And so, you know, he'll be picking the speakers and setting up the schedule. And so I really look forward to that. And on the same day, April 6th, Chris Empe from the University of Arizona will be joining us to talk about his journey to the Himalaya to teach cosmology and science to Buddhist monks, young Buddhist monks. And so this is really an interesting book and story and an adventure. So that's going to be a very interesting day, I think. So
What time is Chris's session start?
4 o'clock
Your time.
Central Time. Yeah. So I look forward to that.
Would you let me do a little poem in front of that?
I'm sure we could do that. So
Yeah, I think I'd like to. I'd like to hear Chris's talk.
yeah, for sure, for sure. Are you friends? Do you know?
Yeah, I know Chris very well.
Oh, excellent. Okay.
Oh, I could say we're deep enemies, but we're not. I'd be lying. I know him very well. I have a huge amount of respect for the man.
Well, Molly, I think you have some live images that you're bringing down right now. Is that right?
Yes, but there's not much to see. You can kind of see the Medusa Nebula. It's in monochrome because it's a color image, but Sequence Generator Pro does not have a debayer preview. But I can put it up and
Let's see what it looks
you
like.
can take a look. Give me just a second. It's on my other. There we go.
Oh no.
What? So I use Chrome Remote Desktop to run both of my laptops that are sitting outside my backyard.
Okay.
And so I have them both up and running right now, so I can just see what's on the screen and control them from inside, which is really nice.
That is
and
nice.
Sometimes when they're not happy with the guide stars available, I'll tweak some of the settings so that it'll get a good guide star.
Well, we can throw the computers across the yard.
Say that again, sorry.
I said you could throw the computers across the yard, and when they bounce back, exactly what you want to see.
That's how I fixed the internet connection here at H4 Scientific.
Yeah, you just gotta show them who's boss. You gotta say, hey,
yeah, you gotta show the
stuff. I'm gonna toss you out the window, and
how loud can you slam a laptop shut?
Ooh, I don't want to break the screen though.
I did that. I've had this old laptop here. I've had tantrums with it, and I've slammed it shut. It's never broken, and it still works. And
I find that when I'm nice to my computers, when I close them gently, when I speak sweet nothings to them, tell them how good they are, and maybe pet them a bit, they don't misbehave. I haven't had to slam my computer.
I found that too. That's a wonderful theory.
That does not work. I can tell you that does not work here in our office. So.
It works for me. It's all I'm saying.
The nicer you are to them, the worse they get.
Every morning I go out and greet my telescopes as they've done their night's work, and I give them a little pat and make sure they're all spit spot and tickety boo, and gently put the covers back on them and say, oh, you've done a good night's work tonight, telescope, and let's go look at what images you pulled in last night. And yeah.
Well, on a slightly related subject, Molly, I lost my wedding ring last week.
Wow,
and I really was upset about it because it is my wedding ring, and it is a Gibeon meteorite ring.
Oh.
And it's the third one I've had to keep our marriage happily going.
Oh no.
And I was looking all over the observatories and everything. And I went in to the observatory where Eureka is. And right next to it on the ground, there it was. And
wow.
This is
your telescope kept it safe for you, of course.
Yeah. I didn't expect to find it. I was so excited. I hugged the telescope. I was so pleased. There were actually two telescopes involved, Eureka and Flare, the 14-inch from Meade, which was right nearby, and it had a roll in it as well. But I was so pleased that I got it back, and here it is. And now I'm going to put it back on. Hopefully that my marriage will go on a little while longer now.
Oh, goodness.
That's the way to lengthen the life of any good relationship. But Wendy is really an incredible companion for David, and I mean that this married couple is just something that when I think about David and Wendy together, it makes me smile. So. And how long have you been married now, David?
24 years. So last week. 24 years. So we're planning something big for next year.
Oh, yeah.
We're going to sit down on our couch potatoes and watch television like we did this year. This was a fabulous anniversary.
Well, you can do like what I did for my birthday this year during the pandemic, which was order myself a nice meal on DoorDash and sit here and celebrate it alone.
Well, I think we have to say happy birthday to you, Molly.
Oh, it was like 2 months ago. Don't worry.
It's always your birthday. It's never too late. To you.
Well, see, the sad thing was that I turned 30 this year, and that's usually when you want to go out and be like, get drunk about. But I couldn't do that this year, so I just had wine by myself with my cats in my apartment, which is really fitting for a 30th birthday, to be honest. So.
Oh.
Oh.
In 2 months, I will be having my 73rd birthday. I am so old now, Molly.
Well, you're still younger than my grandparents, so don't feel too bad.
Yeah, that's right. Yeah.
You still have grandparents.
My grandparents are almost, they're just about 80. So you're just a little younger than them.
Well, you are very fortunate to have your grandparents.
Yes, yes, yeah, they're
I
very
still miss my
healthy, and I'm
grandparents so
hoping that they'll
much.
be around for a good long while yet still. So I hope I
My
have
story
their
about
genes.
this telescope relating to my grandparents, because I was carefully saving up the money to buy it, and then Grandpa started asking me, "Well, what are you going to use it for?" I said, "To search for comets." And he said, "Well, what's the matter with the scope you have now?" I said, "Well, this has a wider field." And I explained a wider field. And he said, "Okay." And I said, "What do you mean, okay? Okay, what?" And he said, "Okay, you can buy the telescope." And I was about to say, I was saving up to buy the telescope. I don't think I need your permission. And he said, "Here's a check. I'm going to buy this telescope."
Ah,
Oh my goodness!
That was something else.
Wow.
It
yeah.
was really, really something.
Almost jumped out of your
And
socks.
so this one has a lot of memories. Another memory is while I was on my practice marriage honeymoon, for the marriage did not work out. My wife decided, we were on this long cross country trip. My wife decided that she was going to have an affair with somebody else because she wanted an open marriage.
Oh,
And they came back after a while and they said, we couldn't do it. And I was thinking, so what? And she said, no, 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 he wouldn't do it because out of respect to you. So we're all going to go get some pizza. Would you like to come? And I looked at them. I looked at them.
Oh my
And I
gosh.
said, frankly, I'm having a lot more fun with this inanimate telescope than I am with either of you. So you go by and have a good pizza, and I'll
Oh
stay
no.
here.
oh my goodness. God, David,
Well,
just for that, the next time I see you, I'm going to buy you and Wendy the biggest pizza you've ever had.
Oh yeah. There was a place in my hometown up in Spokane, Washington, that sold what they called the monster pizza, and it was I don't remember the dimensions of it, but it was monstrous. Like a slice of pizza would be like twice the length of your plate, basically.
Oh,
And so that's what they would always get for all the sports teams and stuff like that, because it was just up the road, and you could order like 10 pizzas and feed your team, and the boys would eat like a whole pizza to them each to themselves. So
geez.
Oh, how interesting. One of the advantages of being ancient as I am is that I don't eat as much. And however, but I'd look
They're a
forward
bad
to
thing.
Scotty's pizza when he next comes. Actually, you're going to see a whole lot of changes when you're here next, Scotty,
Oh, yeah?
because we're having the main building rebuilt. The
Oh, yeah.
roof was torn off, and we're rebuilding it now. It's being put on as a new roof, and the
So
base is still there, but the roof is being replaced as we speak.
did you take before and did you take progression
Oh
photos?
yeah, I even have pictures of the remains of the original roof,
Yeah.
which is still on the ground there,
Mm-hmm.
and that's a lot of fun. It's taking shape now. We're getting pretty excited about it. So I hope one day all of you can actually come and see our observatory
One day we
and
will.
see what I got out there. Scotty,
Yeah.
you've been out there. We're going to have a star party in 2022, hopefully.
We are definitely having a star party in 2020.
Definitely, Scotty the optimist.
That's right. I don't care what kind of virus they throw at us, we're going to make
Yeah,
it.
now we're gonna have a super pandemic.
We have to arrive in bubbles. Okay, we're doing it. Okay, so
Yeah, we really need to do it. I've been getting so used. I'll bet you Molly are the same. We're so used to this lockdown that I don't know how we're going to get out of it. I mean, I'm totally comfortable here.
Yeah, it's been hard. So my classmates, we've gotten together outside, socially distanced, whatever, and I'm so easily overwhelmed now by like lots of people and lots of like stuff going on, because it's very quiet it's just me in the house and my cat. So it's very just quiet and everything is ordered and exactly how I like it. But then when I'm out with other people, it's just like there's so much going on, and I like forget how to have conversations, like just talk about myself and never ask any questions of anybody else. I forget how to have a conversation. And yeah, I think a lot of people are going to be feeling that. And yeah, it's when I went home for Christmas this year, I didn't social distance from my family or whatever, so I kept subconsciously backing up from my parents, and then being like, wait, why am I doing this?
Been vaccinated yet?
Right.
Not yet. So the vaccines just opened to all adults in my county that I live in here in California. So I've sent in my form. They're gonna contact me to schedule my appointment. Hopefully I can get that ASAP, but it's gonna be crazy because they just opened it up. So I'll keep my fingers crossed I can get it soon.
We are getting our second vaccine tomorrow.
Excellent.
And I have heard, as I said earlier tonight, that everybody who's had the second Moderna vaccine has died from it. So I'm expecting I'll be dead tomorrow. But I will still come back and do the next GS with you guys.
Well, David, we missed, you had a good life, we'll miss you. We'll start working on your obituary.
I don't think anybody's died from the second vaccine.
I don't think so.
Nobody.
I know one. Yeah, I don't know.
I've heard
Nobody. We're a little bit nervous about it, but
have your chicken soup and water and Pedialyte ready, because
chicken soup with matzo balls, and we're going to do that, and we're going to get ready for the GSP. I got a lot of homework to do to practice for next week, but
you're the most practiced one here, David.
Actually, I think Molly, you did a damn good job tonight.
Thank you.
I think we should all applaud
Yes,
Molly. I think
right.
that's great.
That's right.
Thank you.
Molly, you did a great job, and great lineup. So who all did we have on today? Do you remember?
Let me pull up my spreadsheet. Hang on.
So many. She needs a spreadsheet.
And if you know me, like, oh yeah, of course she has a spreadsheet.
Right, with graphs.
So we had my minion, Michaela Weller, who's an undergraduate at Ohio State University, the Ohio State University.
All right.
It's a thing out there, so
Mm-hmm.
Anna Parra on exoplanets. We had Stella Kafka from AAVSO.
Yeah.
We had Chris Elliott and Roy Salisbury from Fraser Cain's Virtual Star Party series. We had Terry Mann from the Astronomical League, who is super awesome and super supportive, and she's been awesome to. I was in the same Astro Club as her, and we hung out a lot. We have Will, of course, Deep Sky Dude.
Yep. Sky Dude.
And
Thank you so much.
Yeah. My friends.
I really enjoyed your presentation tonight, Will.
Yeah.
Oh, thank you. That means the absolute world to me, because again, I grew up with you as a mentor, whether you didn't know it at the time, but in Sky and Telescope, I just read all your articles, and there's actually home movies of me watching a pixelated TV, because back when you didn't have cable, you had to get it through an antenna. And there's video of me having my mom's video camera filming the TV with you being interviewed about Shoemaker Levy 9 hitting. I was like, this is happening right now. And I was like maybe 10 or something, but I was filming the television so you could see where it all kind of started, right? So
that was something else. I remember Wendy and I weren't quite together yet, but we were getting closer. And one of Wendy's friends called her and said, turn on the TV. Which channel? All the channels. Your friend is on.
That's so cool.
Awesome. Very cool.
Well, thanks. I remember we were having one of the press conferences that week, that wonderful week. And I was sitting, Gene and Carolyn weren't on that day, but in the middle of the press conference, Gene walks in and he points at me and he says, come here, come here. And I looked at the lady sitting next to me. I said, nothing is going to get me out of this press conference. And she said, that's good. And I sit there and I said, no. And he comes, come on, you got to come out. And then he comes running up to me. He says, you got to leave. We've been invited to meet the president. And I looked at the lady and I said, except that.
Yeah, bye.
He just says, get out of here.
Oh my goodness.
That's cool. That was very cool.
Amazing.
Wow.
Well, it was okay. We got to meet Bill Clinton, which was kind of nice, but the real highlight for us was meeting Al Gore. We had a nice talk with him, nice presentation, and it was almost like he was this amateur astronomer, just like all of you, asking questions and saying that he got to see it from the telescope on his property.
Mm-hmm.
And we just had this wonderful conversation with him, almost as if he was, and he's about just a little older than I am right now, which would date him a lot, but and me. But we really enjoyed that. It was great fun.
That's so cool.
Well, and who else did we have? We had John Briggs on, Livy and the Stars.
I think Libby did great tonight.
Andrea, how do I pronounce her last name?
Huronis.
Huronis, yes.
I did not ask her how to pronounce her last name. I should have. And Sarah Krug, a good friend of mine. Sarah actually came with me when I drove out from Ohio to Wyoming for the solar eclipse in 2017. And she came out to Alcon with me that year. And because they put Alcon like in conjunction with the solar eclipse in Casper, because that was super smart of them to do.
Yeah,
and so give us an excuse to spend more time out there. They set up a dark sky site for us to do some astronomy on the backside of the major mountain over there. I think it's actually called Casper Mountain. And yeah, that was a really amazing trip, and the weather was perfection for the eclipse. So
yeah, we were in Oregon. We saw Madras, Oregon.
Yeah, you got good weather too, didn't you, David?
Yeah.
It was good weather everywhere except for like Indiana, I think.
But all the rest were pretty good. I think
In St. Joseph,
a lot of people saw that eclipse.
St. Joseph, Missouri. I was being Michael Bakich was not begging me, but taunting me, telling me that there was a 4% better chance of clear skies in I think it's called St. Joseph. And I go, well, I'm already committed to Casper. We got to go to the Alcon and all of that. And I said, I know you guys are going to have a great time. So him and, had a big group out. He had a big group of people, and, Michael does an excellent job, except that the clouds did roll in. So, which is too bad. Some people took off and actually did get to the outskirts of those clouds and were able to see something. But yeah.
One of my friends went down to Tennessee, which was a much shorter drive from Ohio, but I was not willing to place my bets on the clouds in that area. So I made the very long drive out to Wyoming, and it was totally worth it though, because we had great weather, and also Alcon was fun. Although the drive back was something.
The drive back was horrendous.
So we stayed. I wanted to stay through the end of the eclipse, like all the way to fourth contact, for the image I was making, where I was going to have all the phases. And so we were one of the last ones out of there. And when we hit so there's an interstate that goes from Casper and it turns south and goes to Denver, which is where everybody who was flying in instead of driving goes to Denver, because I think Casper has an airport, but you don't really go there. So they're all driving south to Denver. But in order to continue east back to Ohio, we had to be on that freeway for about 100 miles. And that 100 miles took 6 hours.
Yeah, it was
traverse.
just it was a big parking lot.
Yeah, and the gas station at a town, I can't remember the name of the town, starts with the G, but they were running out of gas. And fortunately, my car has the auto engine shut off, so that when you're stopped under certain conditions, it will shut off the engine. So I only burned a quarter tank that whole 6 hours. Thank God, because there was no gas at that gas station. Lines were so long. So as soon as we got off the interstate, it was smooth sailing all the way back to Ohio. But yeah, it was a long day.
Speaking of Ohio, one of your friends who was talking tonight was at Miami University.
Yeah.
Yeah, and I was going to say that Miami University was on Jeopardy last night.
Oh, was it?
Yeah. They want to know what state Miami University was in.
Oh, yeah. Yes, there's a funny, you know the show The Office?
Yeah.
One of the women on the show, she like in one of the later seasons, she's like, I got into Miami University, I'm going to Florida. She's like, ditches her coat, and she's like, I don't need this anymore. And then of course, Miami University is actually in Ohio, not in Miami, Florida. So yes, you need your coat in Ohio.
I first heard about Miami University by reading Starlight Nights by Leslie Peltier. And they gave him their 12-inch Clark refractor that was at the observatory at Miami University.
Wow. Yeah, he was, so the astronomy club out there is the Miami Valley Astronomical Society.
Yeah.
And they actually put, Dayton, Ohio, like on the t-shirts and stuff because people think it's Florida. But yeah, Leslie Peltier's was actually he had a merry-go-round telescope, and it's installed at our observatory site. And members can use it. I've never seen anybody use it.
Is that the original or one that was rebuilt?
Yeah, it's the original.
Oh my goodness.
Yeah.
I'd like to see that sometime.
It's cool. Like I've never actually really seen anybody use it, but when we're doing our qualification to get keys to the observatory, they show you like that you can access it and how to use it and stuff. And it's got this like padded chair and like a turret style wheel that you turn to, and the whole thing turns around, so you're sitting all comfy in this chair and you're just aiming the telescope by turning these wheels. And if you want to have a comfortable observing session, that's a good place to do it.
We discovered several comets using the merry-go-round observatory.
Is it this one right here? I'm sharing my screen.
Yeah.
That's it. I will check it's it.
So check that out. He was inside that enclosure.
Yeah.
Yeah.
So he just kind of built that on a merry-go-round, I guess.
Yeah.
And,
From the Delphus Toy Company.
that is awesome. So what still exists? Just the platform itself, or
the telescope? There's a telescope in there too. I will admit I am not really read in on the history of, like, I think we had a few presentations on him at the club, and there's some plaques and stuff up around the observatory, but I don't know a whole lot, unfortunately, and I haven't looked inside of the merry-go-round since I first saw it, so I don't know what telescope is in there, but there is a telescope in there.
I wouldn't be surprised if it's the original, because I don't think it's been touched since he passed away.
It may well be. I don't remember it being a newer telescope. It wasn't something that I recognized. So
because not many telescopes would fit into that. In fact, not many people would fit into that.
Yeah.
Leslie told me there's no way I'd be able to squeeze into it, because he had to be a very short person.
It's a pretty tight fit, yeah. Yeah, there's all kinds of really cool stuff out of that observatory. We have a really long refractor that goes on this permanent pier that's inside this little roll-off. It looks like an outhouse, and you roll it off. And they used to put it up every year at the Apollo Rendezvous event, and it was just this huge refractor. I can't remember what the aperture is.
My guess is it will be a 12-inch.
Yeah, it's got to be something like that. And unfortunately, I don't know a whole lot about the telescope.
It might have been the one from Miami University, in fact, that they gave to us.
I don't remember.
I don't know. Sorry.
I need to figure these things out. I need to learn that.
So some of the people watching the program right now may not know who Leslie Peltier was. David, how would you describe Leslie Peltier as an astronomer?
The thing that he said, not in Starlight Nights, that I could repeat, is that he said, if any of you are thinking of becoming an amateur astronomer, I strongly advise against it. It is like a disease, because as soon as you catch it, there is no hope of getting rid of it, and you will have it for the rest of your life, and you will love your life and you will love this disease.
Yep.
He was so passionate about the night sky, so poetic. And he's written a number of books, but Starlight Nights is one, you know, if I were on a ship and the ship was sinking, and the ship had a library with every book published from the Bible all the way, every book in the history of the world, and they let all the passengers choose just one book that they'd have for eternity on a desert island, I'd take Starlight Nights.
Wow.
Because that's by far my favorite book.
Mm.
Absolutely by far. I think I've read my copy like 16 times now. And it's just incredible.
I haven't actually read it, but I should.
Well, you really must.
Okay.
And if you don't like it, I will refund your purchase price.
All right. I'm easy to
With a
please.
guarantee like that, you can't pass it up. So
That's right.
that's right.
All right. Well, I gotta have a meeting at 8:30 tomorrow, and it's not as late where I'm at as it is where you're at, Scott. So.
I also have a meeting at about 8:30 in the morning. So, but it was wonderful to have the 39th Global Star Party with you, Molly, and all the great people you brought on. Will, thank you very much for coming on. We met at the first time at Star Party in Texas, Durango. Is that right?
El Dorado.
El Dorado. Okay.
Yeah,
Yep.
absolutely.
So, that's right. Greg Bragg introduced me to you and said this is a great guy, Scott, and he was right. So.
Well, thank you. I was just on the phone with Greg today, and he's a great guy. He's one of my best friends in astronomy, and he's always been super kind to me. I don't know why. He's just always been super kind to me and super friendly, and he's just such a great guy. And so it's people like that are in the astronomy community that are so great, like you and David and Molly. You know, I met Molly one time at Texas Star Party, but we hung out basically every day, essentially around the campus or whatever, and you become friends with people immediately because of that. And so I feel that way about all you guys, and so thank y'all for having me on. I really appreciate it.
And it's great to get to meet you, Will. Hope I'll
Thank
see you
you.
again.
Yeah.
Take care.
Absolutely.
And thank you all, and we'll see you next week.
That's right. Okay. All right. And so thank you very much. And Molly, again, thank you. And especially thank you to the audience that watch us until what is now becoming the wee hours here. Pekka was already having breakfast and
yeah.
coffee
He's
and
getting his
stuff,
day started over there.
a bag of donuts, and so anyhow, thanks so
Hey,
much.
Can I share a couple of things as a going away?
As a going away
Yeah.
gift, sure you can.
Okay, here we go. So let me just share my screen here. Okay, so basically,
You were being very quiet back there, Cameron.
I mean, yeah, good. There we go. So basically, so I managed to get, let's see here, go back here. Sorry. There we go. Okay, so I got the Eskimo Nebula.
Oh, nice.
Good.
Oh,
But-
yeah. We always call that the clown face nebula.
The clown face, yeah, love that one. And then I also got
Right,
the
yeah.
Ghost of Jupiter, and I got the central star of
Oh,
Ghost
wow.
of Jupiter.
Structure inside of that.
Yeah. And then I did catch, no, that's Ghost of Jupiter again. Yeah, and then this is the best I could do with Markarian's chain.
Yeah,
You
that
can
one
see-
would be hard to get, I think.
It's hard, and I can see a couple of things. I just don't have a wide enough field. This is a Schmidt-Cassegrain, so that's the best I can do. And then I was just taking a picture of M3 here. Give me a second. Let's go to 3200.
Infrared reflection nebula.
Yeah, exactly. So if we could just take a quick snapshot, I think I have M3 in here. Oh, I have to move this out of the way. There we go.
There it is.
Oh, nice.
So I got M3. There you go. So have a good night, everyone. Thank you all.
Okay,
It was
thank
awesome,
you.
awesome session.
Right.
Thanks, everyone.
See you
Good
next
night.
week.
Yeah.
Good night.
All right. Good night, everyone. We'll see you tomorrow on our 4 o'clock show. And until then, wishing you clear and steady skies. Take care.
Good night.
Good night, all.
Bye,
Good
guys.
night. Thanks, Molly. Good stuff.
Good stuff, Molly. Yep.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.